Okay, so now we are going to talk about oceanography. ओशनोग्राफी में सबसे पहला टॉपिक इज ocean bottom topography. Next comes ocean temperature. उसके बाद salinity, ocean deposits, coral reefs, oceanic currents and circulations. After that, we'll cover about even El Nino and its related phenomena like La Nino and the others. So सबसे पहला ocean bottom topography, just for the basic understanding as to what things are beneath the ocean water. So first we have is continental shelf, then we have continental slopes. This- After that we have continental rise, abyssal plains, canyons, seamounts, volcanoes, volcanic islands, guyats, guyats, and then we have mid-oceanic ridges and trenches. So first, continental shelf. So if you can see from the diagram, this is continental shelf. These are continental slopes. Then continental. This is continental rise. This is abyssal plains. These are mid-oceanic ridges. These are seamounts. These seamounts एक ग्योट्स होता है जिसका ऊपर का there is no top pyramid. These are volcanic islands. So now starting, and these are the trenches which divides the ocean, which is due to the subduction or anything. So सबसे पहला we'll start with the continental shelf, wherein the average depth of water below the continent from 150 to 200 meters, and here we see 90% of the maximum live marine. This till this depth the sunlight reaches, and that is the reason why biodiversity exists in this region. Life is very abundant and diverse, and we see a maximum biodiversity in this continental shelf. The maximum nutrients plus oxygen are found in this region itself. It is very rich in sunlight plus oxygen, which favors the growth of planktons. It is very rich in diversity and it is known for large scale fishing zone. The shelf it is wider along the plain areas near to the coast, and they are narrow near to mountain coast. Next example, there is east and western coast of USA. So after that comes continental slope. It is the boundary between the continent and the oceans, which is formed by outer edge of continents. It is much steeper than shelf. After that comes continental rise. Continental rise is the base of continental slope with low gradient, and it ends or continues till abyssal plains and absent along the trenches. Next comes submarine canyons. These are the canyons which are formed along the continental shelf and slope, and this is because of the turbidity currents. जैसे कि we have Ganga Canyon, we have Indus Canyon. Next comes abyssal plains. Abyssal plains, these are tectonically inactive plains or oceanic floor with very smooth surface, and they are covered with different kinds of oceanic deposits. Next comes mid-oceanic ridges. Mid-oceanic ridges, as we have learned in the landforms itself, this is because of the oceanic divergent plate boundary. Next comes trenches. Trenches, these are associated with the subduction zones. As we have learned in the landforms itself, that because of the collision of the two continents, the continent with the lower density subducts below and forms trenches. These are very deep in nature, and these are the deepest points which we found in the on the earth. Next is sea mounts. Sea mounts are the generations of oceanic convergent plate boundary. ये भी हमने पढ़ा है landforms में, and these are uh, isolated volcanic mountains on the oceanic floor. Next we have coyotes. Coyotes, they are flat top hills which summits below water level. and it does not have a top, but around it we see many of the biodiversities being flourished as we learn about coral reefs going forward. It provides rich support for life, which is resulting in fishing soon. Next comes volcanic islands or the islands or the archipelago, which is again because of the mid-oceanic ridges, and it is found in the regions which is associated with ocean convergence. अब आ जाते हैं ओशनिक टेम्परेचर. ओशन का भी टेम्परेचर होता है, इट इज वार्म, इट इज कोल्ड एट सम पॉइंट्स. Now the question is, what factors determines whether the ocean temperature will be high or will be low? The first and foremost factor is depth. The more the depth of the ocean is, the lesser will be the temperature. Because with the increase in the depth, the biodiversity starts to decrease, the sunlight it receives decreases, thus making it more colder in nature. Next comes nature. Nature may we have a concept of specific heat, in which we learned that the lands they have a very high specific heat. That is, during summers it heats up very fast, and in the nights or during winters it cools down very rapidly. However, in case with the oceans, we see that the oceans they gradually take time. It takes time for the oceans to warm up, and it takes time for it to get cooler down. So this again, this specific heat concept, it determines the oceanic temperature. So the first one which we learned is about the depth. The more the depth is, the temperature will be lesser. Second, we learned as to about the nature of the surface. The third is winds. The stronger the winds are over the oceans, it helps in the better temperature distributions. As we know, there are two types of so these winds influence the currents, and it flows in such a way so that it can distribute a temperature which is moderate at each and every place. So there can be instances that at the polar sides, the water is very cold. So these distribution of winds, these influences that cold water to mix with the warm water. So this helps in maintaining the temperature. Next comes ocean currents. We are going to learn about the ocean currents, but for the purpose of maintaining the temperature of the oceans, oceanic currents plays an important role. They help in the heat distribution between the tropical and the polar regions. As we know that the water temperature at the polar regions are very cold. It goes up to minus. So in order to have that heat balance, there is a heat distribution through ocean currents. Next is distribution of land mass. Now these seas, they completely surrounded by the lands. They have a tendency of high temperature in comparison to the oceans, which are very wide in nature and have open oceans. Next, distribution. So the factors which are going to affect the ocean temperature are: first one, depth; second one, it's nature or specific heat; third one is winds; next is oceanic currents; and the last is distribution of land mass. नेक्स्ट आ जाते हैं डिस्ट्रीब्यूशन के ऊपर कि किस तरह से ओशंस डिस्ट्रीब्यूटेड है थ्रू आउट. नाउ टेम्परेचर ऑफ द ओशन वाटर डिक्रीज होता है विद डेप्थ, दिस वी नो. नाउ द पैटर्न ऑफ वेरिएशन चेंज होगा लैटिट्यूड के हिसाब से कि वो किस लैटिट्यूड में लाई कर रहा है. दैट विल डिटरमाइन दैट बाय व्हाट टेम्परेचर इट इज गोइंग टू डिक्रीज. The first area of such zone is called as epheliminion. Epheliminion जो होता है 200 मीटर ऑफ डेप्थ के फ्रॉम दी sea level होगा, and the average temperature here lies between 20 to 25 degrees near the tropic zone of constant sunlight. Plus, they have a uniform temperature when the wind starts to mix. This is a zone of abundant life, as we have learned earlier as well that in the continental shelf area, the maximum of the biodiversity exists. The second point which comes is thermocline or मेटालिमिनियन. मेटालिमिनियन में टेम्परेचर रैपिडली डिक्रीज होता है विद द डिक्रीज इन डेप्थ, एंड जिसको हम ट्यूलाइट जोन भी बोलते हैं. Third is hypoluminian. Hypoluminian is the zone of uniform cold temperature. Now, as we know that the water temperature can reach up to maximum of 4 degrees Celsius. Reason being, if the temperature starts to get below 4 degree, it becomes lighter in density, and again it comes upwards, and which leads to increase in the temperature. Thus, the maximum density, maximum temperature of water can be 4 degrees Celsius, and this maximum density at this temperature, and इसको हम dark zone भी बोलते हैं. So we have three zones: epimilinian, thermocline या metamaluminian, and hypoluminian. So as you can see from this diagram that we have depth on the uh, vertical axis and temperature on the horizontal axis. Now, in the region of Apolymenian, the temperature lies between 20 to 24 degree. After that starts Metaluminian, wherein the temperature first remains constant and gradually decreases and suddenly dips. After that, we see in the hypoluminian, the dip of temperature continues. So this was about distribution of oceanic temperature, and if we talk about the horizontal distribution of such temperature, so we'll see that along the tropical region the surface temperature is between 25 to 20 degree. Near the temperate region it will be lower and it will decrease rapidly, and if it's a polar region, temperature it will uniformly remains cold. Next comes the concept of salinity. Salinity is the concept that what amount of dissolved salt is present in the 100 grams of seawater, which is measured as a part per thousand, that is ppt. Average salinity of a water is around 35 ppt. Now, how do we get saline or the salt in the water? So there are various factors which results in increase of salinity and which results in decrease of salinity. Now for increase in salinity, the first one is sediments. Now the sediments which is coming because of the weathering of rocks, erosion of rocks, which is brought by the rivers, that results in increase of salinity. Second one being volcanic eruptions. So whenever the volcanoes erupt, the magma coming out of the volcanoes have a content of salt, which increases the salinity of the water. The third being evaporation. Now, as we know, the evaporation processes, it leads to decrease in the water level. Now, if you increase the salinity or decrease the water, it will have the same effect. Therefore, because of the evaporation process, the salinity of the water increases due to decrease in water level. Similarly, with the ice formation, when the ice forms, it removes or it leaves all the salinity behind, thus resulting in increase in the salinity level of oceans. So these are the four causes which results in increase of salinity. First one being increase in first one being sediments, volcanic eruptions, evaporations, and ice formation. Next comes decrease in salinity. How there will be decrease? Fresh waters अगर है तो salt precipitation, that is the oceans, they have a limited capacity to hold the salt. Now if the amount of salt increases, this will lead to deposition of the same in the oceanic floor. Third being rainfall. If the water level increases, the salinity will decrease. Last being ice melting. As we know, ice formation leads to the increase in salinity. The ice melting will decrease the salinity of the water or the oceans. Next comes what are the factors which affects the salinity. First being temperature. If the temperature is very high, evaporation process will be faster and it will lead to increase in salinity in the water. Number two, winds. If the winds are more or high, it will lead to high evaporation, causing increased salinity. Third being oceanic currents. The distribution of salinity between the tropical and polar regions. It also impacts the salinity of the oceans. Now, let's understand how the salinity is distributed amongst the oceanic water. So if you see, first is the polar region. In the polar region, it is very low saline. It's low salinity. It occurs near to the surface by there is low temperature and there is lower rate of evaporation. Polar region being cold in temperature leads to lower temperature and lower rate of evaporation leading to decrease in salinity. So polar regions में salinity बहुत कम रहता है. Number two, along the subtropical regions, it is high salinity near the surface. Why? Because there is high evaporation and it sharply decreases to become uniform after a certain depth. तो एक डेप्थ के बाद वो नॉर्मल हो जाएगा. थर्ड इज इक्वेटोरियल रीजन्स में बहुत हाई प्रेसिपिटेशन है तो इवेपोरेशन नहीं हो रहा. इट लीड्स टू लो सैलिनिटी नियर द अपर लेयर्स बट डेप्थ में इट इंक्रीजेस एंड देन इट बिकम्स यूनिफॉर्म आफ्टर अ पॉइंट ऑफ टाइम. So if you understand from the diagram, this is the depth, this is the regions. So अगर पोलर रीजन का बात करें, सैलिनिटी कम है, धीरे धीरे बढ़ता है, देन यूनिफॉर्म हो जाता है. इक्वेटोरियल पे बात करें, कम रहता है, फिर इंक्रीज होके देन बिकम्स यूनिफॉर्म. सब ट्रॉपिक्स में हाई रहता है एंड देन इट स्टार्ट्स टू ग्रेजुअली डिक्रीज एंड देन बिकम्स यूनिफॉर्म. डन. नाउ उस सॉल्ट के अंदर कौन कौन से डिजॉल्व्ड केमिकल्स या फिर एलिमेंट्स प्रेजेंट होते हैं. फर्स्ट इज क्लोराइन विच अमाउंट्स टू which proportions whose proportion is 18.97%. सोडियम जिसका 10.47 है. सल्फेट एंड मैग्नीशियम. You have to remember the chronology. CSSM, chlorine, sodium, sulfate, magnesium. Now regions. There are some regions present wherein the salinity is above the average level, which is 35 ppt, and there are some regions where the salinity is very low. Now increase in salinity के factors हमने पढ़ा क्यों increase हो सकता है, and decrease in salinity के भी हमने factors पढ़े कि क्यों इतना decrease हो सकता है salinity. Now there are seas. The number one sea is Arabian Sea, wherein we find that the salinity level is 36, whereas the average we have learned is 35. So 36, it is because of higher evaporation because of the strong chill. Next, Red Sea, Persian Gulf, Mediterranean Sea, subtropical regions of Atlantic. ये सब जगह पे salinity बहुत high है. There are some regions which are below salinity level. First one being Bay of Bengal, and Bay of Bengal में there is very low salinity due to fresh waters being merging into that ocean. Black Sea, North Sea, यहाँ Black Sea में भी 3 rivers आके merge होते हैं. North Sea, Arctic Ocean, Bering Sea, Southern Ocean. Now Lake Van is the lake which has the highest salinity level and it is around 330 ppt. Next is Dead Sea. Dead Sea, it has, which is falling between Israel and Jordan, it has a salinity of 240 ppt. Next comes oceanic deposits. ओशन के जो ग्राउंड लेवल है एबिसल प्लेन्स पे कुछ डिपॉजिट्स प्रेजेंट होते हैं. Now those deposits में one of the important one is what we know as coral reefs, other one being petroleum. There are other sand, रेड क्ले, पॉलीमैटिक. तो इसको हमने चार पार्ट्स में डिवाइड कर दिया है. पहला है टेरिजेनियस. टेरिजेनियस आर द डिपॉजिट्स विच इज ओरिजिनेटिंग फ्रॉम द लैंड. जैसे कि सैंड हो गया, क्ले हो गया, मड हो गया, क्ले नहीं सॉरी, मड हो गया, silt हो गया. So these are originating from the land. There is biogenous. Biogenous जो है is getting originated from the life inside the oceans. For example, coral reefs, shells, ooze and petroleum. Petroleum भी dead organisms के fossil fuel से बन रहा है. So petroleum. Hydrogenous. This is getting originated from the waters in the ocean. For example, polymetallic metallic nodules, polymetallic sulfides, and the third one is red clay. There are cosmogenous deposits as well. This cosmogenous deposit is the result of meteoritic debris. The important one is coral reefs. Coral reefs क्या होता है? Coral reefs are masses of limestone and dolomite. लाइमस्टोन एंड डोलोमाइन का मास है जो कि अक्यूमुलेट होता है बाय लाइम सिक्रीटिंग ऑर्गेनिज्म, जिसको हम कोरल पॉलिप बोलते हैं. So it's a colony of the coral polyp which is accumulated at a place, and these are lime secreting organisms. ये डेवलप होता है बिकॉज ऑफ द सिम्बियोटिक रिलेशनशिप बिटवीन द कोरल पॉलिप्स एंड द algae zooxanthellae. Now the question is why there is a symbiotic relationship between the two. This is because this is because This is because the coral polyps, they provide habitat through building the reefs, and on those reefs the algae settle down and they provide nutrients through photosynthesis. So algae, they perform the process of photosynthesis, just say the coral polyps, they receive all the nutrients. Now those nutrients, as they are mixed in the water, so they are filtering animals, which filters the water and absorbs all the nutrients from the same, and they releases back the water in the ocean. Coral reefs होते हैं, coral reefs, they are the host of nearly 31 phyla of animals, which results in rich biodiversity, and they are called as rainforest of the oceans, and they are the largest living organisms on the planet Earth. क्या कंडीशंस हैं जिसमें कोरल रीफ्स एग्जिस्ट करेंगे? पहला कंडीशन इज that there should be a temperature which is more than 20 degree Celsius. अगर टेम्परेचर बहुत कम होगा, they will not be able to survive. Depth should be less than 20 to 20 to 50 feet, so that they receive the adequate amount of sunlight which is required for their survival. Salinity of water should be average. It should not be much more. It should not be much lesser. Why? If there is a differences between the two, it will lead to extinction of such coral reefs. Clear water होना चाहिए because they filter the water, and this acts as a new food for them. So it should be sediments free. And platform to build colony of coral reefs, that is the continental shelf. बहुत large continental shelf होना चाहिए so that they can settle down there. Distribution, अगर हम देखते हैं तो कोरल रीफ्स मेनली 30 डिग्री नॉर्थ, 30 डिग्री साउथ में प्रेजेंट होते हैं. व्हाट इज द रीजन? बिकॉज एट दैट जोन द वाटर लेवल का टेम्परेचर जो है इट इज 20 to 25 डिग्री, क्योंकि अगर हम पोलर रीजन या टेम्परेट रीजन में चले जाते हैं तो वाटर का टेम्परेचर लेवल बहुत डिक्रीज होने लगता है, एंड दैट इज नॉट सूटेबल फॉर द कोरल रीफ्स. नेक्स्ट, ऑन द वेस्टर्न मार्जिन ऑफ द कॉन्टिनेंट्स हम देखते हैं कि कोरल रीफ्स बहुत यूजुअली मिलते हैं. क्वेश्चन इज क्यों? बिकॉज देयर इज अ प्रेजेंस ऑफ कोल्ड ओशन करंट्स इन द वेस्टर्न रीजन्स ऑफ द कॉन्टिनेंट्स, एंड कोल्ड ओशन करंट्स में दे कैन नॉट एग्जिस्ट बिकॉज दे नीड वार्म टेम्परेचर. रीजन में रीजन्स कहाँ कहाँ दिखते हैं हमको? कोरल ट्रायंगल एक है साउथ ईस्ट एशियन आइलैंड्स में, देन नॉर्दर्न ऑस्ट्रेलिया में जहाँ पे ग्रेट बैरियर रीफ प्रेजेंट है, नॉर्थ ईस्टर्न ऑस्ट्रेलिया हो गया, वेस्टर्न इंडियन ओशन, पर्शियन गल्फ, पैसिफिक आइलैंड्स। अगर इंडिया का बात करें, लक्षद्वीप, अंडमान एंड निकोबार आइलैंड, मलवान ऑफ महाराष्ट्र, ये भी डेवलप हो रहा है, गल्फ ऑफ मन्नार एंड गल्फ ऑफ कच्छ। मडागास्कर में भी मिलता है, गल्फ ऑफ मेक्सिको भी है, कैरेबियन सी में भी है, but they are not found along the Leeward Delta because of the fresh water and sediments being present. जैसे कि ईस्टर्न कोस्ट ऑफ इंडिया में प्रेजेंट नहीं है क्योंकि डेल्टा बहुत ज्यादा है इधर एरिया में। नेक्स्ट कम्स उडुपी इन द नेत्रानी आइलैंड, उडुपी इन मैंगलोर, इट इज प्रेजेंट। कितने टाइप्स ऑफ कोरल रीफ्स होते हैं? देयर आर थ्री टाइप्स ऑफ कोरल रीफ्स। फर्स्ट इज फ्रिंजिंग रीफ, सेकंड इज बैरियर रीफ and third is atoll reef. Third is atoll reef. Types of coral reef में fringing reefs क्या होते हैं? Fringing reefs, they are very narrow coral reefs and they are lying close to the coast in a discontinued form and patches. So patches of coral reef आप देखो बहुत ही छोटे छोटे सब जगह प्रेजेंट होते हैं, जैसे कि वेस्टर्न कोस्ट ऑफ इंडिया में है, अंडमान एंड निकोबार आइलैंड में है, कैरेबियन सी में है। सो ये फ्रिंजिंग रीफ है। नेक्स्ट कम्स बैरियर रीफ। बैरियर रीफ ये आर वाइड एंड कंटिन्यूअस कोरल प्लेटफॉर्म्स, वाइड एंड कंटिन्यूअस कोरल प्लेटफॉर्म जो कि लोकेटेड है वेरी फार फ्रॉम द कोस्ट एंड दे आर सेपरेटेड बाय लगून्स। ग्रेट बैरियर रीफ जो बात करें ऑस्ट्रेलिया में, दैट इज अ एग्जांपल ऑफ बैरियर रीफ। थर्ड वन बीइंग अटॉल रीफ। अटॉल रीफ जो है दे आर सर्कुलर कोरल रीफ्स व्हिच आर प्रेजेंट इन द वोल्केनिक आइलैंड्स। उनका जो टॉप होता है उनका या फिर गयोट्स, इससे पूरा सराउंडिंग यहाँ पे प्रेजेंट रहते हैं। जैसे कि लक्षद्वीप है, पैसिफिक आइलैंड्स है, उसमें इसी फॉर्म में प्रेजेंट है रीफ्स। कोरल ब्लीचिंग क्या होता है? नाउ दिस इज द वेरी इंपॉर्टेंट फैक्टर। कोरल जो है दे रिसीव्स देयर कलर फ्रॉम द एल्गे, because coral polyps they are transparent in nature, but algae they give color to the algae zooxanthellae, they give color to those coral reefs. Now coral bleaching ho gaya when they lose their color. Why? Because of the stress induced expulsion of zooxanthellae, which is the algae present hai. If we are removing that algae from the corals, it will result in coral bleaching. Now the question is, why there is so much of coral bleaching happening and why it's a matter of concern? Due to changes in the water temperature, the ocean is getting warm and this is resulting in pollution which causes the algae or the symbiotic relationship to get over. If there is changes in the salinity, it impacts their living. If there is change in pH, pH is ocean acidification. If that gets impacted, if there is increased sedimentation, then if there is increased incidence of storms and cyclones in the ocean, then if there is pollution, if there is overfishing or oil exploration or oil spill, या फिर El Nino. Now, there have been recent episodes of large-scale coral bleach in 1997-98, which resulted in large-scale bleaching in the Indian Ocean. 2014 to 17 में there was bleaching happening in the Great Barrier Reef. Now comes ocean currents. Now ocean currents में क्या होता है ocean currents? This is the general movement of surface water which in the ocean in a definite direction over the long distance. Now दो तरह के ocean currents होते हैं, एक होता है warm, एक होता है cold. Warm current move करता है low latitude से high latitude जैसे equator to pole, and cold current flow करता है high latitude से low latitudes. क्या फैक्टर्स है जो इम्पैक्ट करते हैं ओशन के करेंट्स को? फर्स्ट इज विंड. स्टेडी ब्लोइंग विंड ऑफ winds होंगे, इट विल ड्रैग द सरफेस वाटर and it will lead in its direction and they'll bring about the surface flow and steadily they will set the water currents in motion. Next is variation in the temperature, salinity, density. This causes the water to move and reduce the variations and reduce the variations. Such differences they guide the movement of ocean currents. Next comes the shape of the coast and the oceanic topography. This also decides they modify the ocean currents. Coriolis force, if the winds or the ocean currents they deflect right moving in the northern hemisphere and left if they move in the southern hemisphere. Next comes, so this is the diagrammatic presentation of how the ocean currents are flowing. ओशन करेंट्स में अगर बात करें, अटलांटिक ओशन में वी सी वेरियस फॉर्म्स ऑफ करेंट्स. फर्स्ट इज नॉर्थ इक्वेटोरियल करंट, साउथ इक्वेटोरियल करंट, काउंटर इक्वेटोरियल करंट्स, एंटिलेस करंट, फ्लोरिडा करंट, गल्फ स्ट्रीम, नॉर्थ अटलांटिक ड्रिफ्ट, कैनरी करंट, नॉर्थ वेगियन करंट, लैब्राडोर करंट, ईस्टर्न Greenland current, Brazilian current, west wind, South Atlantic, Peninsula, and Falkland. Pacific Ocean में there is Oceano current, North Pacific drift, Californian current, Alaska, East Australian, South Pacific, and Humboldt. Oyashi, Cortices. थर्ड आ जाता है इंडियन ओशंस, मोजाम्बिक करेंट्स, एग्युलिस करंट, एग्युलस करंट, वेस्ट विंड ड्रिफ्ट, वेस्ट ऑस्ट्रेलियन करंट. ये करेंट्स इंडियन ओशंस का फ्लो दिखा रहा है. नाउ करेंट्स ऑफ नॉर्थ इंडियन ओशंस. नाउ विल टॉक अबाउट कि विंटर्स में कैसे फ्लो करता है और समर्स में कैसे फ्लो करता है. अगर विंटर्स का बात करें तो जो नॉर्थ ईस्टर्न करंट है दे स्टार्ट्स फ्लोइंग वेस्टवर्ड. So these are the northeastern winds. They starts to flow westwards, leading to movement of water from Bay of Bengal to Arabian Sea in a counterclockwise direction. So the northeast current they flow westward above the equator, and counter equatorial current they flow between northeast and southeast current. नॉर्थ ईस्ट मानसून विंड ड्राइव करता है द वाटर ऑफ बे ऑफ बंगाल इन द अरेबियन सी इन काउंटर क्लॉकवाइज डायरेक्शन, जिसको हम नॉर्थ ईस्ट मानसून ड्रिफ्ट बोलते हैं. ड्यूरिंग दिस टाइम नॉर्थ ईस्ट करंट और काउंटर इक्वेटोरियल करंट दे आर एब्सेंट. सिर्फ हमको साउथ इक्वेटोरियल करंट देखने को मिलता है. What are the significance of ocean currents? This is important. If there is a movement of ocean currents, it helps in global distribution of temperature and salinity. If there is continuous movement of water from east to west, tropical regions में cold water upwelling happens, and then along the eastern parts, it results in drop in the temperature. If there is accumulation of warm water along the eastern coasts, it will lead to rise in the temperature. The western parts of the tropical ocean, they experience favorable conditions, that is warm ocean currents, which leads to the formation of cyclones, resulting in frequent cyclones. Coral reefs, they are found in the abundantly along the western parts of the oceans within the tropical regions. Near subtropical regions, under the influence of cold ocean currents, the western margins of the continents, precipitation suppress हो जाता है, due to desiccation or dehydration, which leads to the formation of deserts. एग्जाम्पल्स हो गया कैनरी करंट जो हमको सहारा में मिलता है, कैलिफोर्नियन करंट विच फ्लोज इन मोजावे ऑफ नॉर्थ अमेरिका, हम्बोल्ट अटाकामा डेजर्ट ऑफ साउथ अमेरिका, पेनिनसुला नबीब डेजर्ट ऑफ अफ्रीका, and western Australian current which is flowing in which resulted into Victorian desert of Australia. Now, if there's a merging of warm and old ocean currents, this results in favorable conditions of fishing banks, which we see in Peru and Chile. It is near the Newfoundland island due to the merging of Gulf Stream and Labrador Stream, which is cold ocean current. इससे फेवरेबल कंडीशंस फॉग फॉर्मेशन का भी होता है, एज वी हैव लर्न एडवेक्शन फॉग. सो एडवेक्शन का फ्लो के चक्कर में सो वार्म ओशन करेंट्स आ रहे हैं, कोल्ड ओशन करेंट्स आ रहे हैं, वार्म विल लाई ओवर द कोल्ड एंड इट विल ब्लॉक द साइकिल रिजल्टिंग इन फॉग फॉर्मेशन. वार्म ओशन करेंट्स होता है टेम्परेट रीजन में अलोंग द वेस्टर्न मार्जिन. इससे माइल्ड विंटर होगा एंड इट विल कीप द कोस्ट आइस फ्री थ्रू आउट द ईयर. North Atlantic drift along the UK coast, Alaska current along the western Canada is an example. Offshore winds push करता है surface water को away and it causes cold water upwelling from the bottom to rise up, and then this brings the deep cold water and the nutrients from beneath the ocean. This brings, which is rich in water on the water surface, which led to the development of fishing banks and other related economic activities as fertilizers industry of Peru and Chile. Ocean currents help करता है in navigation of open oceans as well. Next concept is upwelling, downwelling. Upwelling, downwelling. जब offshore winds push करते हैं ocean surface water को away and causes the cold water from the bottom to rise up on the surface, so they are pushing this away, and then ये जो cold water यहाँ पे they will rise up. This is called as upwelling. And downwelling होता है जब onshore winds they pile up the water near the coast and causes the sinking of water below the surface. Why? Because of the salinity it has, density increases, so it will start to sink down. Upwelling बहुत active होता है western margins of the continents में with tropical regions, and downwelling active है in the regions जहाँ पे warm and cold ocean currents meet करते हैं. Polar regions में there is ice formation which leaves the water saltier and denser, causing it to sink. Next concept comes thermohaline circulation. क्या होता है thermohaline circulation? When these deep ocean currents, they are driven by, so whatever currents till now we have learned was more or less about the surface currents. कि surface पे जो water है वो कैसे flow कर रहा है with the help of the ocean currents. Thermohaline circulation is more concerned about the deep ocean currents because those are not standstill. They are also moving. But how they are moving, in what form they move, is what explained by thermohaline circulation. Thermohaline circulation में the deep oceanic currents, they are driven by differences in water density, which is controlled by temperature and salinity. So डीप ओशनिक करंट्स में क्या हो गया, ऐसा पानी है जिसका डेंसिटी बहुत हाई है, सो दे आर लाइंग डाउन एंड दिस इज बिकॉज ऑफ द टेम्परेचर दे हैव एंड द सैलिनिटी, अमाउंट ऑफ सैलिनिटी दे हैव. इसको हम थर्मोहाइलाइन सर्कुलेशन बोलते हैं. नाउ सर्कुलेशन बिगिन होता है नियर द पोलर रीजन्स ऑफ द डाउनवेलिंग, जहाँ पे आइस फॉर्मेशन लीव्स द सैलिनिटी on the water and it becomes denser, which causes sinking. So polar region से start होके ये जो अंडर वाटर करंट है मूव करता है इन दिस सिंगल कंटिन्यूअस बेड. नाउ इतना सरफेस करंट्स क्यों इतना वेव लेता है या इतना फॉर्मेशन क्यों है? बिकॉज ऑफ द लैंड, क्योंकि इतने सारे कॉन्टिनेंट्स प्रेजेंट हैं, इट हैज टू टेक द फॉर्म. बट वाटर के बीनीथ तो इतना कुछ लैंड फॉर्मेशन है ही नहीं, सो दे आर इन अ सिंगल एंड कंटिन्यूअस बेल्ट अक्रॉस द ओशंस. They are connected to the surface water currents in a region of upwelling called as greater ocean conveyor belts. सो upwelling and downwelling जो होता है, that is how deep ocean currents are connected with the surface water currents in the region of upwelling, जिसको हम great oceanic conveyor belt बोलते हैं. Next concept is Atlantic Meridional Overturning Circulation, AMOC. ये पार्ट है किसका, थर्मोहलाइन सर्कुलेशन का, जो कि अटलांटिक ओशन में हो रहा है, नाम से पता चल रहा है. रीसेंट रिपोर्ट तैयार 6 का जो बोल रहा है कि ये जो एएमओसी है बहुत वीकन हो रहा है, वाई, बिकॉज ऑफ ग्लोबल वार्मिंग. लेट्स अंडरस्टैंड हाउ इट इज गेटिंग वीकन. First reason is harsh winters. Along the winter Europe and British climate increase the occurrence of cyclones in the tropical waters. There is disturbance in the fishing zone. There is negative impact on the marine ecosystem due to the disturbed salinity. These are the reasons for AMOC weakening. नेक्स्ट कंसेप्ट आता है वाटर मास. जैसे हमने पढ़ा था एयर मासेस, जहाँ पे फ्रीक्वेंसी ये सब बहुत स्टैंड स्टिल एयर है. सिमिलरली वाटर एयर मास भी ऐसा सिचुएशन है जहाँ पे टेम्परेचर एंड सैलिनिटी दे आर यूनिफॉर्म. तीन तरह के वाटर मास होते हैं. एक होता है सरफेस वाटर मास, जैसे कि अटलांटिक सरफेस वाटर मास हो गया. इंटरमीडिएट वाटर मास, जैसे कि सब ट्रॉपिकल या फिर इंटरमीडिएट वाटर मास हो गया. एंड द थर्ड इज डीप वाटर मास, विच इज नॉर्थ अटलांटिक डीप वाटर मास. सिग्निफिकेंस क्या है वाटर मास का? फर्स्ट, इट हेल्प्स इन द generation of thermohaline circulations. मूवमेंट ऑफ वाटर मास डिस्ट्रीब्यूट करता है टेम्परेचर, सैलिनिटी एंड ऑक्सीजन एक पार्ट से दूसरे पार्ट में. इट रिजल्ट इन जनरेशन ऑफ अपव्हीलिंग एंड डाउनव्हीलिंग. एंड प्लैंक्टन्स ग्रोथ एंड कोरल रीफ्स की डेवलपमेंट में भी हेल्प करता है. Now the concept comes about El Nino and related concepts. पहला we'll talk about water circulation, जो कि mainly अगर किसमें हो रहा है, पैसिफिक ओशन में. Now पैसिफिक ओशन में जो ITCZ है, ITCZ इंटर कॉन्टिनेंटल कन्वर्जन जोन. सो ये जो जोन है ये यूजुअली नियर द इक्वेटर रहता है. नाउ नियर द सदर्न अमेरिकन वेस्टर्न कोस्ट ये ट्रेड विंड्स बहुत स्ट्रांगली मूव करते हैं. Now this movement, these offshore winds, this push the surface water towards the westwards, which is away from the continent. So अगर आप यहाँ देखो कि यहाँ पे पानी है. Now winds, these are very strong in nature and this is leading the surface water to move towards westwards. Now as it moves westwards, the temperature. Now as it moves westwards, इसके नीचे का जो पानी है, this is coming up here. This is upwelling. Upwelling is happening. नीचे से पानी ऊपर आएगा. To cover that up, and convection suppress हो जाता है. कोल्ड वाटर आ गया तो कन्वेक्शन नहीं होगा. वाटर फ्लो करता है वेस्टवर्ड एंड साउथ ईस्ट ट्रेड विंड्स ब्लो करता है टुवर्ड वेस्टर्न पैसिफिक. During this, water gets heated up and accumulated along the Western Pacific, which causes Western Pacific warm. तो ये एग्जाम्पल ले लो कि ये वेस्टर्न पैसिफिक है एंड इस रीजन में, वेस्टर्न पैसिफिक में, यहाँ पे हीट अप हो जाता है वाटर एंड ड्यू टू दिस हीट अप कन्वेक्शन हैपेंस. Now, as the convection reaches the troposphere, it starts to diverge, and by the time it comes near the center or the eastern Pacific, it subsides because of the temperature. So this rises to convection, which is resulting in cloud formation. बहुत ज़्यादा बारिश होगी. The rising air flows eastwards in the upper troposphere and it starts to subside along the eastern Pacific. The sixth circulation complete होता है and that circulation is what is, that convection cell is called as Walker circulation. Now इससे क्या होगा, लो टेम्परेचर और हाई प्रेशर बनेगा कहाँ पर, वेस्टर्न पैसिफिक पे, ईस्टर्न पैसिफिक पे, और हाई टेम्परेचर और लो प्रेशर बनेगा वेस्टर्न पैसिफिक पे. नॉर्मल कंडीशंस में बोला कि ड्यू टू वॉकर सर्कुलेशन ईस्टर्न पैसिफिक बहुत ज़्यादा ड्राउट फेस करता है एंड वेस्टर्न पैसिफिक में बहुत अच्छा रेनफॉल होता है. एल नीनो में पूरा सिनारियो रिवर्स हो रहा है। कैसे? ये एलिनो जो है ये अराउंड 2 से 7 साल के बीच में होता है एंड बिटवीन अक्टूबर टू नवंबर होता है। आईटीसीजेड बहुत इक्वेटर से साउथ मूव कर जाता है एंड इट कॉजेज द वीकनिंग ऑफ ट्रेड विंड्स। क्योंकि ट्रेड विंड्स वीकन हो चुके हैं, ये रिड्यूस करेगा अपविलिंग को एंड द वाटर विच इज प्रेजेंट नियर द वेस्टर्न पैसिफिक ओशन इट इज कोल्डर इन नेचर। Now this sorry it starts to heat up, warm हो जाएगा ये, यहीं पे convection start होगा, rainfall होगा, it will result in precipitation, it will result in wet climate, whereas till the time it reaches the eastern Pacific it becomes dry in nature and causes drought there. I hope I'm right. Causes tropical water to the warm. Earlier west flowing waters they start to flow back eastwards, फर्दर अपफीलिंग खत्म हो जाता है, वार्म सरफेस हो जाएगा एंड इट रिजल्ट्स इन एल नीनो। एयर प्रेशर ड्रॉप होता है नियर द ईस्टर्न पैसिफिक ओशन एंड राइज करता है नियर द वेस्टर्न पैसिफिक। दिस वेरिएशन रिजल्ट्स इन एल नीनो सदर्न ऑसिलेशन। एल नीनो से हैवी प्रेसिपिटेशन होगा अलोंग द ईस्टर्न पैसिफिक एंड ड्राउट होगा इन द वेस्टर्न पैसिफिक। After 1 or 2 3 years, enhanced Hadley circulation strengthen होता है and again the trade winds are strengthened which leads to upwelling, bringing back into normal conditions, and ये normal conditions now takes a form of La Nino। बट ये बहुत ही इंटेंसिफाइड वॉकर हो गया। एक तो वॉकर सर्कुलेशन हुआ, फिर एलिनो हो गया जहाँ पे रिवर्सल हो गया, वेस्टर्न जहाँ पानी था वहीं पे वो हीटअप होके ईस्टर्न में हीटअप होके इट कॉजेज प्रेसिपिटेशन, रेनफॉल, वेस्टर्न में बहुत ही ड्राउट वाला सिचुएशन हो जा रहा है। बट ला नीनो में इंटेंसिफाइड वॉकर हो जाएगा। La Nina में it is intensified higher pressure and cold temperature along the eastern Pacific and very low temperature and high pressure in the western Pacific, which causes severe drought and eastern western Pacific में बहुत ज़्यादा western Pacific में बहुत ज़्यादा rainfall होता है which leads to floods and dry conditions in the eastern Pacific। इम्पैक्ट्स क्या है एल नीनो के? एल नीनो के इम्पैक्ट्स में सबसे पहला आता है इट लीड्स टू डिस्टर्बेंस इन दी वॉकर कंडीशंस, क्योंकि पूरा रिवर्स कर देता है वॉकर सर्कुलेशन को एंड इट कॉजेज डिस्टर्बेंस इन द ग्लोबल वेदर प्रोसेस। इम्पैक्ट ऑफ एल नीनो पहला डिस्टर्ब करता है वॉकर सर्कुलेशंस को, कॉज करता है ड्राउट एंड ड्राई कंडीशंस वेस्टर्न पैसिफिक में and impact करता है rainfalls in India and Australia. It's the onset of monsoon, distribution of rainfall, and the amount of precipitation which gets impacted over the monsoon of South Asia and Australia. It results in heavy precipitation along the coastal desert of Peru and Chile, dry conditions in India and Australia, which triggers forest fire, creates severe dust storms India and Australia में. Warm water inhibit करता है the growth of planktons and algae and suppress करता है upwelling devastating marine ecosystem को which kill the fishes in large scale along the Peru and Chile coast. Deposition of fish in water, it turns it dark, foul smelling and toxic, and it results in catastrophic impact on fishing and fertilizers. El Nino here results in mass coral bleaching. Rainfall creates large scale flowering in the deserted regions. El Nino suppresses tropical cyclones. Next आता है El Nino Moduki. El Nino is characterized by strong warming in Eastern Pacific, whereas Moduki results in warming of Central Pacific. Convection Central Pacific में होगा with dry conditions along eastern and western parts. It creates two cell water circulation over tropical Pacific regions with precipitation along Central Pacific and drought along Eastern and Western Pacific. While El Nino may result is diminished hurricanes in Arabian Sea, El Nino Moduki causes increased incidence. El Nino Moduki results in higher number of cyclones in the Arabian Sea than the Bay of Bengal. Indian Ocean dipole. It is the difference in the sea surface temperature between the Western Arabian and the East Indian Ocean of Australia and Indonesia, and it is called as Indian Ocean dipole. Similarly to water circulation, it is coupled ocean and atmospheric phenomena. पॉजिटिव इंडियन ओशन डाइपोल है तो वार्म सी सरफेस along the western part composed compared to east, good precipitation over India and less rainfall over Indonesia and Australia, higher cyclones होते हैं Arabian में, and it reduces the impact of El Nino over India. Negative में warm sea surface along eastern parts, negative effects on Indian monsoon, ज़्यादा rainfall in Indonesia and Australia, and increased impact of El Nino over India. So this was all about oceanography. There are one or two more concepts like tide winds and all that will cover in the other audio.